Excellent work. Okay, so today we're going to talk about real-world use cases for Microsoft Cognitive Services and also tell you a little bit about the open source offerings that we have for people who either want to roll their own models or just want to leverage the capabilities of Microsoft. So to start off with, I'm Paige Bailey. I worked as a data scientist in the energy industry for about 4.5 years before I started with Microsoft. I began working for Microsoft about 3 months ago, so be gentle if you have very, very in-depth 10 years ago Microsoft questions. I got my background in geophysics and carbonate geology, so that was undergrad and grad school with some applied math mixed in there. And then also got a master's degree in computer science. So I've been playing with Python for about 10 years, R for about 4 years, and using some of the nice Apache open source tools like Spark and Kafka and Hive and all that good stuff for around 2 years. I'm based out of Austin, so if you're ever in the area, please feel free to stop by and we can go get breakfast tacos or coffee or something. I'd be delighted to talk to you. So artificial intelligence and machine learning. As we heard from our last speaker, it is exploding. It feels like everybody wants to be able to incorporate it into their products now. And the sort of scary situation has been that those words come very charged, right? Like if you hear deep learning, everybody kind of thinks like, oh man, that must be super hard, right? Like that must be something that would take hours upon hours and days to do. And have very, very specialized knowledge, or machine learning, right? Like how could one program a computer to predict the future with just data? Like that sounds very complicated. But the reality is that there are a lot of tools available now that make the process super easy. And also the entire idea behind those two processes is to take the work out of the programmer's life, right? So if you're a programmer, you're used to having very explicit instructions that you have to define each time. So you have this big overarching problem that you were tasked with breaking down into small, small steps to teach the computer how to do something. Machine learning and deep learning take all of that work out of it. So instead of you having to formulate those rules, the computer does it for you. So Microsoft's offering, we really have two, right? So you can either create your own model, or you can deploy someone else's. And by deploying someone else's, I mean the entire Azure machine learning teams model, leveraging all of the data that we have as part of Bing, as part of our Microsoft corpus, as part of everything that we've scraped off the internet. So for the first bit, though, for creating your own model, you have a few options. And to illustrate those, I'm going to walk through a case study. So Jabil is one of the world's largest circuit board electronic parts manufacturers, right? They make billions of these circuit boards a day, and they're created through this factory assembly line process, right? So you have a number of people kind of lined up. You have a circuit board going by. They each place one part or kind of observe as a part has been placed. And they make the assessment of, yes, that was correct, or no, that's not correct. We need to remove this board and redo it. And that sounds like the most boring job in the world to me. So don't know about you guys, but that is something I would love to automate. But these people, they look at screens kind of similar to the one that you can see there on the right, that have the images go by with like the little parts, and what we created was this dashboard that can help guide you as to whether a part has been installed correctly or not. And how did we do that? So this chip, it looks like it's been appropriately installed, right? So you have these little silver connectors. They're attaching it securely to the board, and that would be considered a pass. This guy, no chip is present. So I don't know what happened to it, right? Like it dashed away to France or something. It went on vacation. I don't know. But like the chip is obviously not there. So that would obviously be a fail. And if your boss came up to you and said, hey, Paige, or hey, Dimitri, or hey, whoever, like I want you to design a program that would be able to look at these pictures, and say whether it was a pass or a fail or not. Immediately, your programmer brain would start thinking like, okay, what could I possibly do? Like, I could look at this picture, I could kind of sample the center of it, you know, the pixels in the center, and if they were kind of orangey, then I would say like, okay, there's probably not a chip there, so that's probably fail, and that's fine. So that's what we'll do. And your boss will say, well, that's great, but what about this one, right? Like there's very obviously no orange stripe through the center here, but it's still been installed incorrectly. So how are you going to go about doing that? And you would think, well, so I'll have to come up with a rule for that picture too. And that would be hard. And then you'll start thinking about how big circuit boards are and how many components are installed on them, and think about how many hundreds of thousands of variations there are in circuit boards, and you will start crying. And that will not be a fun job for you. And if you had to explicitly design every instruction to analyze those images to find out if they were correct or not. So what we did was use a deep learning virtual machine, connected up with the Azure Machine Learning Workbench, and also leveraging some Jupyter notebooks. And it's not fun to tell you about it, so I'm going to show you. Let's see. So if I pull up this guy. So the Azure Machine Learning Workbench is open source. If you want to go download it now, you can. It's free to use. We would be delighted to have you use it. You can use it with Azure. You can use it with the Google Compute Platform. You can use it with AWS. You can use it for whatever. But if you're a data scientist, it's a pretty nifty tool. So this first tab that you see here is a bunch of historical data. And the historical data is because that's what Jabil gave us. So on the left there, you have a circuit board number. And on the right, you have an image path name, right? And it feels like every bit of data that a data scientist gets is like this, right? Like it's kind of a shame to look at. Like you have whether it was a pass or a fail embedded within the path name of the image. Like who thought that was a good idea? And it's not even standardized, right? So you have capital passes and like fails, and then like if you scroll up, you know, some of them are lowercase, and it says failure, and they're parentheses. Like, what is this? but you know, that's what you get sometimes. So you get this corpus of images, you get the circuit board number, and you get whether they're a pass or a fail. So if we go back to our Workbench example, we've imported the text file. We've got the board number on the left, the image path name right here, and as a data scientist in the energy industry, the first thing I would do was think, okay, well, I can either use some of Python's text capabilities and extract whether it's a pass or a fail, so look for those explicit strings after making it all lowercase or all uppercase or something like that, or I could use a regular expression, right? And I could, if I wanted to, you know, hate myself for a while, I could inflict that pain on me and everybody else who would have to look at my code. And that would kind of be the reality. And you would have to do that every single time that you get new additional data. What this allows you to do is there was a thing put out by Microsoft Research a couple of years ago called Project Pendleton. And that was open sourced as well. I can send you the academic papers if you're interested. But what it does is kind of apply machine learning to data engineering tasks. So if I right-click and say derive column by example, what it does is it produces another column with a bunch of nulls in it. And I could just go in and say, well, this is a pass. And this is a pass, and that it doesn't really know quite as well because it doesn't have rules for failures yet, but I'm going to say that's a failure. And it deals with this edge case as well because it doesn't know how to handle parentheses. So I can type in pass there, and voila, it is automatically categorized every single one of those image path names as a pass or a failure correctly. And so you could say like, okay, well, that's fine. You could do a regular expression to do the same thing, and you'd be right. And that's not the cool part, right? So the magic's not the cool part that it's able to extract it. What's cool is that all of those steps that I just did in that GUI are now saved on the right as a deprep file. So if I wanted to package that up and deploy it to an HD Insight cluster or to a Spark cluster on Google Compute Cloud or whatever, I've got that dprep file and it would be able to do it. So suddenly you're able to apply all of that methodology either locally or at scale in the cloud for data engineering tasks. And since a data scientist life is like 85% data cleaning, that's pretty cool. It also does the same thing for JSON files, right? So if you have a JSON file coming in and you want to turn it into a CSV, makes it easy to do that too. So that's the data cleaning piece. Lots of more stuff around Project Pendleton. If you're interested, more than happy to talk to you about it. So you've got your data. What's the next step? You would go and do a model and evaluation. This is a Jupyter notebook. So how many people have played with Jupyter notebooks before? Not enough of you. Everybody's homework is to go home and learn about Jupyter notebooks. And it doesn't matter what language you're familiar with. You can use Python, you can use R, you can use F#, which is crazy. You can use Ruby, anything. And what it does is it kind of gives you an interactive programming environment, right? So you can see here that I'm importing a lot of libraries, so things from Keras, NumPy, Bokeh, which is a Python plotting library, Pill, which is a Python imaging library. I'm clicking Shift-Enter, and what it does is it runs the code in each of those cells as I click Shift-Enter. So you can see that I'm looking at this first board, and it's saying that it's a pass. And as I move forward, it analyzes each one of those images and tells me if it's a pass or a fail. So if I dynamically change this instead of the first circuit board to be the second, click Shift-Enter. So that one's supposed to be a fail. And there you go. It is obviously a fail. It also goes through and it tells you, as you're analyzing these boards, like what the intermediate deep learning layers look like. So you can see how it progresses along that. And the cool thing also, if you're a data scientist, is that as you change your model, as you make any sort of alterations, you can see the performance over time. And I have lost, there it goes. You can see the performance and accuracy over time. And that way you can select your best model, know which one you should actually deploy to production, and have a record of as it performs to make sure there's no data drift as you progress along. It's really difficult to see, but up here on the right it says GPU Linux, and that's because this notebook is running against a deep learning virtual machine, accessing a graphics card, any of the ones that you can select from Microsoft's offerings. So once this has been done, once you've got a model that you're happy with, you can package it up, Dockerize it, turn it into a web service, and have all your applications access it. So that nice example I was showing you before where you have the image and it automatically classifies it with an X or a check mark, that is an actual application built on top of a web service on top of this model and Azure Machine Learning Workbench. So that's cool. And it's free. Don't have to use Microsoft products for anything else. Go home and download it if you'd like to. And just because I do want to tell you a little bit about the virtual machines, because I think they're pretty cool. So if you've ever tried to set up an environment, like a new compute environment, it is not a friendly sort of experience. If you have to deal with package management, so dependencies for packages, and then as things update, right, like as you get a new version, and suddenly that breaks 5 other things, like how do you go about dealing with that? What the data science virtual machines do is we've collected, the litany of things that a data scientist would probably use in their everyday life. So things like TensorFlow, things like Spark, CNTK, Jupyter notebooks, all the Revolution Analytics tools, R, Python, Julia, C#, the NuGet packages that data scientists use, all of it kind of placed into a centralized form. And you can provision a data science virtual machine, and all of that is available immediately for you to use. If you're just a Python developer and you don't want your virtual machine to be loaded up with all that, terrible Julia or C# or R or whatever stuff, then you can just provision the Python packages. And it makes everything kind of a one-stop shop for you to use. If you're dealing with deep learning, driver issues are always a problem. So if you're dealing with graphics cards, and the deep learning virtual machines and the data science virtual machines would take care of that. So a full list of everything that's included is here. You'll notice a lot of open source tools, and you'll also notice that it's not really Microsoft agnostic, or not really Microsoft dependent, right? Like, we've tried to include everything that's good, and that does mean TensorFlow. TensorFlow does have its perks, but so do things like Caffe2. So do things like Torch and some of the other deep learning frameworks that you've probably heard about. So I really love, part of the reason why I came to Microsoft was this newfound commitment to open source. The fun thing is, too, is that for all of our documentation, for every single thing that you see on docs.microsoft.com, there's a little pencil over here on the right. If you click Edit, it takes you to the GitHub repository where it's housed for that page of documentation. And you, no matter who you are, so you can be a Microsoft employee or you can be like a 10th grader in Minnesota or something, but you can make a pull request and make modifications to the documentation if you want to include a cool sample or if something is very obviously wrong. So I think that's awesome. CNTK, which is Microsoft's cognitive toolkit, also open sourced. So if you have any questions about the algorithms, you can go and take a look at the source code. All right. So any questions about that so far? From current slide. Okay. So that was the Jabil Circuit board example. We talked about the data science virtual machines. We talked about the machine learning workbench. We talked about the notebooks, but I guess not really Azure notebooks. And so Jupyter notebooks, as we were discussing before, they're kind of, if I go back here, they're kind of an open source offering, lots of different languages, and what you get is an interactive programming environment. It's really hard to set up a Jupyter Notebook server on your own. So if you wanted to deploy it to the cloud, it would probably take you more than a weekend to get everything correctly. And even then, it would probably be crashing pretty often because of load balancing issues. What Microsoft has done is created notebooks.azure.com, which is Jupyter Notebook hosting. So if you wanted to create something cool and then share it with all your friends, if you had, I guess, better friends than me, because mine don't ever want to see my stuff, then you can use the notebooks.azure.com, get a URL for that notebook, and send it to whoever you want. There is a size limitation of like 4 gigabytes, but you can download your own libraries. You can use, again, any language that you want and share that code immediately. There's also a lot of sort of featured libraries that are interactive introductions to Cognitive Toolkit, to F#, to all of Microsoft's tool sets. So if we go back to the presentation. So what happens when you, well, let's try it out, right? So currently I'm logged into notebooks.azure.com. If I say get started, let's get started with a sample notebook. What it does is it brings up a bunch of existing ones. If I wanted to create a new notebook, I would go to my current libraries. You can see that some are private, so nobody except for people that I give a specialized URL would be able to see it. Others are public. So I could create a URL and send it to everybody, put it on Twitter or whatever. So if this was for a recent conference that I presented at, but it starts a notebook server, spins it up, and this is going through how you would classify bank loans, right? So if you have a CSV that tells you a bunch of information about a person, and then whether or not they defaulted on a loan. So if they paid it back or they didn't, this kind of will run a machine learning model that will tell you the likelihood that they'll default. And it exists as an IPython notebook until you launch the server, and then when you launch that, that's what makes it interactive. If you save it as an IPython notebook file, so let's pop over to my GitHub real quick, and you can see an example there, Azure Workshop. Where is, there we go. So this is the static version of the well-aged bacon example that I had displayed before. So what this did was, and we'll find out how in a couple of minutes, but Cognitive Services went through and analyzed Kevin Bacon over the course of his magnificent career, and determined how old Mr. Bacon looked, and how accurate Cognitive Services was at guessing those things. So you can see here with a singular API call, and you do get a number of these for free, and they're all operating on top of Cognitive Toolkit, so if you have questions about the algorithms, you can go look. You get a JSON blob that tells you everything from and their age to whether or not they're wearing glasses and what kind of glasses. So if it's sunglasses, regular glasses, whatever, exposure, all the information about I write bottom, I write inner, all of that stuff for each person in that photo. So it's not just one person, it's as many faces as it sees in that photo. And what you can see is that is the accuracy kind of listed there at the bottom. So that would kind of be an example of a Jupyter notebook, right? So it's static if you want it to be, like if you want to build a report. But if you want to make it kind of a dynamic, interactive experience for programming, so that you could change whatever's in this cell and it would automatically output underneath, you can do that as well. Jupyter notebooks are really cool. I like them a lot. I've been playing with them for a bit of time, but the extensions that people have come up with have just been incredibly compelling. Like you can even install an extension that turns each of these code cells into a slide deck. So if you hate making PowerPoint presentations, I obviously hate making PowerPoint presentations, then you can just turn your code and your commentary around it, your markdown file, like all of this is just markdown, into a slideshow. And then Shift-Enter just makes it run. Rad. Okay. So, moving along here. Hopefully we don't have another slideshow disaster. So the thing that I just described, the Jabil case study, that's kind of complex, right? So maybe you don't have a data scientist on staff. Maybe you're operating as a startup. Data scientists are expensive. Who needs those people, right? Like, or say you want to do something that's kind of building an app in your garage. Then we have some options for you too. So everything from Microsoft Excel, so actually implementing machine learning in an Excel spreadsheet, to Machine Learning Studio, which is kind of an interactive drag-and-drop machine learning environment, to Cognitive Services, which again is just calling a REST API with any language that you would like to choose. So like I said, so say you have an idea that you watched a movie and you thought it would be really cool if instead of having faces, there were emoticons instead for the entire movie. Or you wanted to have Lego people, so instead of having Leia's face with her angry emotion, then it would be a Lego head with an angry emotion or an emoticon that was angry. And then Han not really caring, there's neutral emoji. Or say you wanted to have one of those crazy things with like the dog ears and the noses for whatever reason, or something like Harry Potter related, because people seem to enjoy that. So those all sound like kind of complicated problems, right? Or say you wanted to put Donald Trump or Vladimir Putin's face on like some random GIF, right? Like that sounds like it would be a hard problem. But in reality, they're all kind of targeting the same thing, right? So they're all taking either masks or kind of little snapshot images and applying them to specific locations on a face. So like the dog ear thing, right? It's just putting it at the top of the head. The nose, it's putting it in the nose direction. The Harry Potter thing, it's putting it kind of in the center of the forehead. Donald Trump's face, just going on top of somebody else's face. And how you would go about doing that is a singular call to the Face API. And that's what I told you, that's what we were looking at before, right? So the Kevin Bacon example. You're able to input an image, input a video file or a GIF, and get in real time the precise locations of features and where faces happen to be. So if you wanted to build an app that would target those specific areas, there you go. All you would have to do is extract those values from a JSON blob. And if anybody's interested in this, I've kind of been, so as I've been exploring Switzerland, I've been making kind of 2-minute or less video clips for how you would go about doing, how you would do precisely that. So we've got one for the computer vision API, which takes a look at a picture and then says what it thinks is in the picture. So this, this case of breads right here, it would actually extract that this is breads in a display case and would give you that raw text in return. The emotion API, that's what we talked about before. And then the translator text API, you give it an input either through speech or through text, and it will give you an output in any language that you want, from Afrikaans to Slovak, like whatever you need. You also have the ability to do chatbots. So the language understanding chatbot, if you just point it at the URL for an FAQ on a website, so again, less than 10 lines of code, not a complicated thing, it automatically creates a chatbot that will give you some sort of output. So this is one that I've created for Day for Night, again, available on my GitHub if you have any questions about it. Day for Night is a festival in Houston, a music festival, because that's my life. But again, the code is incredibly concise because it's just a REST API call. Like what you see here on the left and on the right are two examples of the things that I just showed you. And the sort of guessworky, like, oh, hey, you could do that sort of things, well, they've already been done. So if you have any interest in extracting the code for that, you could see what Suze's created using the Face API in our hotel Wi-Fi. So obviously, you don't need too awful strong of a connection. And Asim created Smile to Unlock, which is if you want to be able to use the face recognition feature for your laptop, your Surface, or your iPhone, all you have to do is smile, and it unlocks it for you. So there are a ton of these things. They're all really simple to use, everything from vision to speech to language to knowledge to search to sort of route optimization. If you're more interested in business problems, right? So if you have a fleet of trucks and you want it to get it from one location to the other in the quickest way possible, and they have constraints, so they can't go on certain roads, these projects can help you with that. And again, in terms of like the difficulty level, right? Cognitive services is actually the hardest thing. So making 10 lines of code in a REST API call is the hardest aspect. And if you wanted to check out, let me go here, Azure Machine Learning Studio. It does all of the machine learning that we were just talking about, so not deep learning, but things like decision trees, things like linear regression, all of that in a drag and drop way. So you just pull in a CSV file, you say what you want to predict on. It gives you guidance based on what you want to predict. So say you want to predict prices in July. That's a numeric value. So it would probably recommend a regression as opposed to a classification. And then it would go about instructing you of how you would go splitting your data. So probably like a 70-15-15 split for testing and training and then validation. You would train up a bunch of different models. And then you would actually have the ability to export the highest performing model as a web service endpoint and put it in an Excel spreadsheet. And that way, anytime anybody added new data to the Excel spreadsheet, it would automatically predict. So those are some pretty cool things, I think. If anybody has any questions about any during the break, more than happy to talk about it. So back to the slideshow. We talked about cognitive services, ML Studio, the Excel components. There are the links, so if anybody wants to go and explore, they absolutely can. Docs.microsoft.com, the data science virtual machines, the deep learning virtual machines, the geospatial data science virtual machines. A lot of them you can get started with for free. So there's like a 30-day free trial. But the nice thing is, too, is that Azure, it now allows for free accounts, so you can register for free. And you also get 12 months of services that if you're not doing things in a production level, you would probably be able to go about like hosting a static blog or a static website. So if you just wanted to have like a one-pager CV or something posted, you would be able to host it on Azure probably for free. And that's it. I'm Dynamic Web Page on Twitter. I'm Dynamic Web Page everywhere on the internet, it feels like. Please feel free to reach out. I would be delighted to talk to you.